Hello, everyone. This is Sushant Rao. I'm Vice President of Marketing for Prophecy. I'll be the host for today's webinar on supercharging your data lakehouse with low-code Apache Spark and Delta Lake. Some housekeeping notes before we begin. We'll be answering questions at the end, so please use the Q&A feature to submit any questions that come up during the webinar. Please do not use the chat. We'll probably miss those, but if you do it in the QA, we'll definitely see those. We're giving an iPad towards the end of the webinar, but you must be present to win. And lastly, the webinar is being recorded and you'll receive an email after the webinar with a link to the recording. So let's start with the agenda for today's webinar. First will be an overview of data lakehouse. Then we'll cover the low-code aspect of a data lakehouse. After that, we'll show you a demo of a low-code data warehouse in action. Then we'll give away the Apple iPad. Remember, you must be present to win. Finally, we'll have a Q&A. Now, let me introduce today's speakers. Our first speaker is Jason Pohl, who is a director of data management at Databricks, and he was one of the first 10 solution architects at Databricks, so he's got a long history with them. He currently leads a team of product specialists who help shepherd new products to market in the areas of data warehousing, data engineering, and data governance. Our second speaker is Maciek Sapowski. Maciek is one of the co-founders of Prophecy. Before Prophecy, he worked on many data engineering and machine learning products and was an avid user of Spark. Maciek currently leads the Prophecy product team. Now, let me turn it over to Jason, who will give an overview of Data Lakehouse. Jason, over to you.
Thank you so much, Sushant. Let me just share this. All right. Thank you so much for having me here today. So as Sushant mentioned, I come from Databricks. So Databricks, we are the data and AI company. We're the inventor and pioneer of the data lakehouse, which I'm going to go into a little bit today. And we're the only vendor that Gartner has recognized as a leader in both database management systems and data science and machine learning platforms. And our claim to fame is being a big advocate for open source software, and we're the creator of the successful open source projects such as Delta Lake for data lakes, Apache Spark, which is the de facto data engineering tool, and MLflow, which has become the de facto open source project for managing the full machine learning lifecycle. I've got over 5,000 employees now around the globe with adoption across lots of different customers, from both small startups to large Fortune 500 companies. So in 10 years, we truly believe that every company is going to be a data analytics and AI company. Even companies today who don't think they need to, consider AI or think about it, I think in 10 years, the winners will all be data analytics and AI companies. And I can give a few examples of that. So we think about this in terms of this AI maturity curve. So we kind of call it from hindsight to foresight. And if you think about it, as you go up on the y-axis, you get more competitive advantage the more proficient you become at artificial intelligence. If you look at the lower left in the red boxes, these are all kind of like your traditional business intelligence, historical looking reporting, where you're basically just trying to understand what has historically happened in your data and your business. So, how many widgets did you sell and who did you sell them to? And why did that number go up or down at a certain time of the year? And what were the other factors? That's all kind of like just trying to understand the past. When you start to get into the purple circles, you start to get into more predictive analytics. So you're trying to predict what's most likely to happen in the future. So what will happen? And then you get to prescriptive analytics, where you might be giving recommendations. So, how should we respond to certain things? Pick from these three. And then at the top right, you've got automated decision making. So this is, instead of just giving a human, a set of options to pick from, let's have the computer automatically pick the best option. And you can kind of think of like self-driving cars as the top right, where they're making decisions, really in milliseconds about how to, accelerate, brake, turn, et cetera. So every company we talk to is on different, stages of this journey in different parts of the curve. And even within a single company, you've got different departments that are different parts of the curve, but everybody's trying to move up and to the right. And the big question is, how do we get from here to there? And it's pretty hard. So it's difficult for most enterprises to do this. And, why is that? So I'm going to go a little bit into exactly why that is. So first of all, analytics is complex because there's actually like, 5 different platforms, at least 5 different platforms involved. It starts off with a data lake. So you've got, a place to put all of your data. It doesn't matter if it's structured data or unstructured data. It could be, as simple as, structured CSV files, or it could be like video or images. And so you need a place to put that. You need to be cheap and you need to be reliable. And the cloud has been phenomenal for this. So, storage solutions like S3 on AWS, it's the cheapest, most durable place to put your data. And you can ETL large amounts of it as well. A lot of customers, especially if you've got a lot of legacy tech, you've probably got a data warehouse or 2 or 10 somewhere in your enterprise. And so what happens is, to be able to run these BI queries, you typically extract some of the data out of your data lake and, clean it up, aggregate it and put it into a data warehouse, and then run your BI queries against it. But to do that, you have to also think about governance and security. So when you're dealing with structured data in a data warehouse, you're dealing with governance from tables and views and making sure that, there's fine-grained access sometimes for even row level, column level security. And you have to make sure that only the authorized people are getting to view the data that they're authorized to see. When you're dealing with data lakes, though, historically, these data lakes have been governed by files and folders. So, you're either allowed to access everything within a folder or nothing. But it's been really hard to do fine-grained governance, because if you wanted to grant access to only certain columns in a table, it's incongruent with, also giving that same person access to the underlying folder as well. And typically, data lakes have been used, they've been successful for data science and machine learning use cases, because whenever you're training these machine learning models, it really behooves you to be able to train your model on the most granular data. So, the lowest level transactions, the clicks that somebody takes on a website, you want to be able to get to that data. And so in some other use cases, you might have, images or videos that you want to do deep learning on. So you need access to those raw files, and data lakes are really good for that. And increasingly, there's been more use cases when it comes to real time and streaming. So I used to build data warehouses many years ago, and everybody always wanted a real time data warehouse, but it always seemed to be, phase 2. It was never like done in phase 1. And then phase 2 also never seemed to come, because it was just too hard to do streaming on traditional data warehouses, because they're optimized for, really short or really, good aggregation queries. But when it comes to writes, they're optimized for bulk writes. They're not really optimized for streaming, much less being able to stream in and trickle in a bunch of small records while people are running these larger analytic queries. So, with all these different use cases, you kind of like end up either, buying a separate system for all these different platforms, or you can create one platform with the lakehouse. So whenever we talk to customers, we hear a lot of these things over and over again. And the 4 truths that all of our customers seem to, come back to is, they want to be able to simplify their data architecture. So they want, fewer moving pieces. They want to drive optionality with open formats. They don't want to be locked into proprietary technology. They don't want to, sign another, Oracle contract. They want to plan for multi-cloud. There's a lot of customers today who say they'll never be in multiple clouds, but then I've got other customers that, they acquired a company that was on a different cloud, and now they've got 2 clouds. We're also seeing people leverage the benefit of having multiple cloud vendors for being able to do arbitrage across their contractual agreements. And also it helps because some cloud regions, they're just running out of capacity. So being able to plan for that is becoming more and more important for companies. And then finally, just, the customers we talk to, they really believe that they need to embrace ML and AI as the future. Otherwise, they could get left behind. So the lakehouse, which I talked about, it simplifies all this. So if you think about it, the data lakes that you can put on cloud storage, they've already got the capacity to put as much data in there as you want. They're super cheap. You can't find a cheaper place to store data. It's already super reliable. So you can put all of your data there in one place. You want one security governance layer to be able to govern data, based on if it's a table or if it's just a collection of files, or more so, being able to govern not just the data, but the machine learning models itself. And then you want to be able to do all of your use cases. So, from everything from AI to BI, you want to do your historical data warehousing look back queries, as well as train your machine learning models to be able to predict the future. And increasingly, you want to be able to apply streaming to this as well, especially if you're creating features like the last sales for the last 10 days per customer. You want to be able to update that in real time and use those features for other models in your enterprise. So you really need all these different use cases. So when you break down, what is our guiding principles and vision? Number one, we want to consolidate and address key friction points. So we don't believe you need to have a separate data warehouse to keep a copy of your data just to run these older historical looking queries. We feel like you should be able to run those type of queries on the same platform against the same single set of data that you use to train your machine learning models. We want to deeply integrate with the ecosystem. So Maciek's going to showcase Partner Connect, which is something we have built into our platform, which allows us to basically integrate with all of the most popular vendors in the modern data stack, including Prophecy. We want to leverage open formats and standards. Everything we do at Databricks since the beginning has been focused on doing it so in an open way. So that way, we create these open source projects that end up becoming the de facto standards in their relative domain. And then we want to make sure that Databricks is the best place to run those open formats. And finally, we want to meet users where they are. So a big part of why I'm excited to do this webinar today is because I think Prophecy is an amazing product. And it's, some of the users that we have on Databricks, they want to be able to, work with their data in a way that doesn't require them to do any coding. And I think something like Prophecy, it really expands the total addressable number of users that can leverage Databricks that otherwise, might have been too intimidated to write code. So that brings us to, the Databricks Lakehouse platform. It's our three key principles, or it's simple in the fact that you can do all of your use cases on a single platform. It's open. We build this on open source using open standards, and we contribute back to the community as much as possible. I would argue more than any other vendor. And then it's multi-cloud. So from the beginning, we've always intended for Databricks to be on multiple clouds, and now we're on the top 3 public clouds. And we're able to leverage the economies of scale from these cloud vendors and also provide those same benefits back to our customers. And then going back to these 5 different platforms and how the Lakehouse simplifies this. If you think about all the different components, Delta Lake is the most popular open source data lake format out there. So it's we have exabytes of data that get processed on Delta Lake every month. Jobs and workflows, we have an orchestrator built into the platform called Databricks Workflows, which I think Maciek's going to show. And this allows you to basically orchestrate anything. We got started by orchestrating Spark jobs, Apache Spark jobs, but you can orchestrate anything that happens to be, Python, SQL, Scala, or R. It doesn't really matter. Unity Catalog, we just went GA with Unity Catalog not too long ago. And Unity Catalog is going to be the single unified governance layer for all of your structured data, unstructured data, as well as AI models and dashboards, notebooks, et cetera. So all of your data assets, they're going to be governed in one place using a standard set of APIs. Databricks ML is our offering for being able to do machine learning and data science. This includes notebooks to be able to do interactive exploratory data analysis, but also machine learning model serving layer, as well as a feature store that allows you to keep those up to date and serve it either in batch or online. DLT, Delta Live Tables, is our simplified way for doing ETL, and then streaming is a lower level way to basically make sure that you can get data and transform it from A to B as fast as possible, and maybe even include machine learning as part of that stream. Databricks SQL is our offering for data warehousing. So you can basically easily spin up a SQL warehouse within Databricks, and using our Photon engine, you can process that data as fast as possible. We created this Photon engine, and last year we won the world record for being able to do the TPC-DS data warehouse benchmark. So we won that after, I think, Alibaba was the former holder. And then finally, Redash is a dashboarding we've built into Databricks. Redash is another one of the open source projects that we host. And you can use Redash. It's hosted, it comes with Databricks, but we've got optimized connectors for all the most popular business intelligence tools as well, like Power BI, Tableau, and Looker. So with that, I'm going to turn it over to Maciek to actually, show the thing you guys really want to see, which is the demo. All right, take it away, Maciek. I'm going to stop sharing.
Perfect. Thank you so much, Jason. Appreciate the nice words, and thank you so much for being here with us. So this was a really good, deep introduction into the data lakehouse. Hey, everyone. I can see that there is a lot of attendees here today, so super excited to be here to tell you how Prophecy Low Code can make your data lakehouse on Databricks even easier. So starting on a little bit of a lighter note, as we have said, the traditional on-premise data warehouses, which are glued together using code and scripts, is like living in the Stone Age, right? With data lakehouse and low code, on Prophecy and Databricks, you can modernize your data stack akin to evolving to the space age. So it's like going from Flintstones, where you have to use your feet to propel the car, all the way to Jetsons, where you can use the tremendous amount of speed powered by the best engines.
So Maciek, that sounds great, right? Moving from the Stone Age to the space age with lakehouse and low code. But does low code mean no code? I mean, there are folks in the audience who like code.
Yeah, absolutely. That's an awesome question. We're actually going to deep dive into it a little bit during the demo as well, but absolutely not. Low code implies that all the code is still there for you, produced. It's just that it's so much tremendously easier to do it, right? It requires lower effort from your side, but code is still there, and it's actually really high quality code automatically being created for you. So that being said, let's step back for a second and think about the challenges of operationalizing your data lakehouse. So Databricks provides this really good architecture as the underlying system, but after going to market and discussing with data experts, we have found those three major challenges. First of all, there is not enough talent. As we all know, data engineering is hard, and currently to be productive and gain any insight from your data, you need to have a workforce of those skilled data engineers. Hiring and training them is very difficult, as they have to essentially learn about the underlying distributed systems at work. Well, very often, even if you do manage to do that and you hire the best of the best engineers, they end up writing this repeatable code for each of those data pipelines. That's simply not productive. Second of all, the collaboration between the teams is pretty low. So currently, every single member on your team, or even between the different teams, is writing code that is often duplicated. Additionally, making this code reliable and pushing it to production is difficult. It requires a whole new skill set. The challenges of standardization and robust operational practices have been solved, however, by the software engineering teams years ago that have introduced all those concepts like Git, continuous integration, and continuous deployment. Third of all, the teams are not flexible enough, right? Very often what happens is that there is this centralized either data platform team or an engineering team that is responsible for productionization of all of your workflows and pipelines that all the other practitioners are developing. That's really clogging the productivity of the whole organization, as very often those pipelines just have to be rewritten from scratch. The work is essentially doubled. Some companies decide to go with a legacy ETL tools, and those elevate some of those pain points. However, they cannot really handle the big data scale, and they don't really fit well with all the use cases that different organizations have. Well, with those challenges in mind, we looked at the current data engineering, and we deeply thought about what should the solution look like, right? So here are the four aspects of the solution that we have come up with. First of all, the solution should be really easy to use. Doesn't matter if you're a programmer, a DBA, an ETL engineer, maybe even a data analyst. As long as you have the business knowledge to build your data pipeline, you should be able to develop them. And this is where Prophecy introduces the low-code editor that allows anyone to build their pipelines with minimal skill set required. Essentially, as long as your data practitioners know how to write those simple functions in Excel, they'll be able to leverage the big data at scale truly for the first time. At the same time, however, programmers can be also productive, as all the code is being created for them. They can modify it and introduce new concepts. Second of all, everyone wants a solution to be code-based, right? That is pretty much the only way of making sure that you're producing the lowest cost, highest performance pipelines that are still easy to debug and don't have any lock-in. This is where Prophecy produces the clean code for you with all the unit tests and integration tests that create the continuous integration and allows you to build and easily deploy all the pipelines, which encompasses the continuous deployment piece. All of that handled out of the box. Third of all, everyone wants it to be the solution to be complete, right? So there is a lot of those small, narrow tools in the market that are really great at solving very narrow problems. However, that's not what the data engineers and practitioners are looking for. They want to have an end-to-end working product as opposed to something that they have to glue together every single time. Well, Prophecy provides you not only a low-code environment, but it takes all of your pipelines all the way from development to production and also gives you an observability layer on top. Fourth of all, we want the solution to be extensible, right? Every single organization have their specific needs. They come with their own sources, targets, transformations. They even want to build the underlying frameworks by themselves. Well, this is where the concept of the gem builder comes in. We'll talk a little bit about what those gems are, but essentially this enables anyone on Prophecy to build new components into your system and further standardize them across the organization.
So Maciek, you're right, these sound all good. Which of these four, right, for people that are actually using the product, which of them do they like the best and why?
That's a really difficult question. So all of four, I think, are really important. That being said, if I did have to pick one, right, definitely the extensibility piece has been standing out the most, right? Because this is very often where a tremendous amount of companies have maybe tried out before some other low-code tools, maybe they tried out ETL products, and they just found that they were not able to suffice their use cases. Here, doesn't matter who you are. Very often you can just build in the missing piece by yourself, or we can help you out do it. Whenever folks see that being created in Prophecy live in front of them, everyone gets tremendously amazed. So I think that all sounds amazing, probably almost too good to be true. But let's look in practice a little bit more on how it looks like. So we can walk a little bit all the way from the infrastructure, Databricks, and how that integrates really well with Prophecy. So at the very bottom, of course, we have all of our clouds. And as Jason said, Databricks really well works with any single of those AWS, Azure, GCP clouds, even allowing you to create hybrid solutions. On top of that, this is, of course, where Databricks lives with Delta Lake. They even have this really cool multi-workspace functionality that allows you to set up workspaces specific for your development, QA, and production use cases. This is where, on top of that, traditionally people would have to write their code. But with Prophecy, we give you this visual to code interface that allows anyone to build their pipelines really, really quickly, just by dragging and dropping essentially those gems, which are your sources, targets, and transformations. This is really cool because even as you're developing your pipeline visually, you see all that hard work being turned into high quality code that you can even start learning from. Underneath, as we said, everything is built out of those gems, the sources, targets, transformations. The beauty of the product is that you can very quickly add more of those gems by yourself. If there is another team that has built some transformation that you would like to reuse, they can just expose it to you as a gem and you can be productive on it. This is very often where all the integrations are also built, even with something like Data Lakehouse. Prophecy, of course, has a really good native integration with Databricks. So we give you out of the box, as an example, all the best Delta Lake integrations. If you just want to write data, of course, that's very easy. But if you want to use more complex use cases, right, merging your data into Data Lakehouse or using something like an SCD2 logic, now you no longer have to write all that code by yourself, but you just drag and drop a specific gem and very quickly fill it out. At the same time, of course, we don't want you to just be productive on your development view, but go all the way to production. this is where the integration with Databricks workflows come in, where anyone can just start dragging and dropping the pipelines directly on the low-code jobs editor. And that in turn creates you those Databricks workflows. You can then orchestrate them directly on your workspace and start monitoring them end to end. What's the better way of knowing than that your pipelines are succeeding if not actually looking at the profiles of the data for every single one of your jobs? And so Prophecy makes that super easy through this end-to-end monitoring interface. Oops, there we go. At the same time, this whole life cycle lives completely on your code, right? So all the way from development, where you're dragging and dropping your gems, writing your code, everything is being stored as commits on your Git. You can create branches. Those branches then can be pulled and reviewed by your whole team through this process called PRs. And then the tests and the unit tests and integration tests can run for you automatically by leveraging the continuous integration. As soon as that you're confident that your code is correct and it's doing the right thing, you can very quickly push it out there to production, leveraging automated continuous deployment. All of that stuff is handled for you automatically. So even if you might have not understood some of those concepts like commits and PRs, you don't have to worry about them. You're leveraging all the best practices out of the box very quickly. Awesome. So that sounds great. What about actual use cases? Well, Prophecy and Databricks works with many different Fortune 100 companies, and this is where usually the most complex use cases are, right? If we can handle those complex use cases, there is nothing else that pretty much remains. As an example, we have worked with top 5 healthcare company, Fortune 100, who used to be on an old on-premise system using many different data warehouses that were stitched together using scripts and ETL products. They had thousands of production pipelines that were running on that system and producing 300 gold, what could be the gold alternative tables essentially in that old system. All of that was built and maintained by over 100 ETL developers. And on the consumption side, they had tremendous amounts of almost thousands of business users and analysts and other data consumers that are leveraging all of this data. Very quickly, however, over the last few years, they started facing problems. They had to, of course, start hiring more ETL developers. That was difficult because no one really knew those old systems or how they worked together. And they stopped being able to scale with more and more data flowing into their old system. So they have decided to migrate to the new solution on cloud, natively sitting on top of Databricks and Delta Lake. And that has been working out really well so far. We've essentially built a centralized set of standards and frameworks for them so that every single person, doesn't matter whether they had existing Spark experience or not, could be productive on all of those data pipelines and could productively start building out their Feather reports directly on cloud. Awesome. So enough with slides. I know that slides are sometimes boring. Let's look into more fun stuff, which is the demo itself. So there's a couple of things that I'd love to cover in the demo. First of all, we're going to look at the lakehouse architecture. So this is where what Jason was mentioning. We're going to look at a little bit the medallion, a set of pipelines, some silver, bronze tables, see how clusters are set up on Databricks, and then deploy from their own Prophecy. We're going to create a completely brand new data pipeline, which is going to compute some monthly recurrent spending, just to show how easy it is to build that pipeline from scratch. We're going to schedule it using Databricks workflows and promote it all the way to production using CI/CD. With all the code running in production, we're of course going to review that code as well, look at it a little bit on GitHub, high quality that code is, and then start observing as our data is flowing through in those production pipelines. We're going to monitor, look at some data profiles. Cool, so let me just switch my tab. So this is the Databricks interface, right? Pretty much for you to be productive, the only prerequisite is to have the Databricks workspace set up. As soon as you have that and some data that you want to start playing around with, you can immediately become productive. So I do have my lakehouse database created here. For the purpose of this demo, I have a few simple tables that we're going to start working with, and I have my cluster running. And this cluster, of course, is Photon enabled as well, right? So it's going to really show how fast all of this data is processed. Now you might wonder, how do I now switch from the Databricks interface to the low-code Prophecy interface? As we have mentioned, Prophecy is one of the Databricks partners, really well integrated. So this is where with just one simple click, you can just open up the Prophecy interface and sign in directly here. With that, the only thing really you there need to provide is essentially your password, and this interface will open up for you. And this is the Prophecy data engineering interface. So what we're going to do now is we're going to build a complete end-to-end reporting system, again on Spark and Prophecy. We're not going to just build any report. It's going to be reliable, production-ready data pipeline. And we're going to set up this whole project on Git, develop our pipeline, schedule it, look at the CI/CD, and even look into the observability layer. That sounds like a lot, but you know what? We're going to do all of that in under 10-15 minutes. So let's get started. Now that we're in the Prophecy interface, I can go and explore my projects. This is where my Supercharge Delta Lake project is, where I already have some pipelines that are existing. With that, I can also see that this project is connected to my Git. So as we start the development, all this hard work that we're going to be putting is going to be turned into high quality code here with all the comments and release notes as well. We're going to look into that into a little bit more detail in a second. But for now, let's get started. So let's build a brand new pipeline within our Supercharge Delta Lake project. This is going to be our gold report pipeline. So we're going to leverage all this ingested data and start building a report on top of that. Perfect. So now that we have this interface opened up for us, this is essentially the low-code canvas. There is few important things to bear in mind here. So on the top right, we have our cluster attach functionality. So with just one click, I can go ahead and attach to my existing cluster on Databricks. This is the same Photon-enabled cluster that we were looking at before. On my left top, I have all of the gems available, right? So those are my sources, targets, transformation, joins that we can just start dragging and dropping into our canvas and building up the pipeline itself. At the bottom, we have all the Git information for us. This might be a little bit more for the expert users, but you can already see that the hard work that we're putting in is turned into those uncommitted files that soon we're going to push through to our production environment. So let's go ahead and start building our pipeline. I already have some of my silver datasets ready. So as you can see, they're all here. I can just start dragging and dropping them directly onto the canvas. So I have my silver orders. Perfect. I can, of course, also drag and drop my customers here as well. But let's actually build out one of those sources from scratch. So I'm just going to create a new source. And this is going to be a new data set, in this case, connected to my existing catalog table. Prophecy, of course, supports a variety of different data connectors. Pretty much everything that Databricks and Spark supports, we support as well. Plus, there are a few other enterprise-specific connectors. If you're missing anything here, those can be added really easy as well. So for now, let's go with the catalog table. This is going to be my silver customers data set. I'm going to choose my lakehouse database and connect to my customers table. With that, we can very quickly look at the underlying schema behind my data set that is loaded up from our catalog. And of course, if we do want to modify any of the properties of how we are reading the data, just to make it more performant, we can very easily do so as well. Awesome. So this is our schema. We can also load up the data live from the cluster, just to look at the little bit of a preview of that data, make sure that this is the exact data set that we're looking for. Perfect. This is our customers' data. Awesome. So now that we have both of those data sets loaded up, let's actually start building the transformations themselves. This is where first step that we might want to do is actually join this data together. So I can drag and drop the join component, and I can connect it directly to my orders and customers. Transformation components are really interesting in Prophecy because we enable you to be as productive as possible. On the left-hand side, you always see the schema of the data sets that you're working with, right? So I can see my orders and customers columns. And on the right-hand side is where you can start writing your transformations. So let's join on my order keys. And let's just give this, my customer keys. And let's just give this component a better name. Perfect. So now we have our joint first transformation developed for us. We would of course like to make sure that we are doing it right. So I can very quickly just click on the play button and start seeing the data flowing in real time here for me. As this data is loading up, we're still working here with quite a big data set. So let's just go ahead and keep building our pipeline. I will drag and drop my aggregate component, connect that together. And this is where I'm going to start calculating some of the monthly report spends. So in my group by, of course, I would like to group by my customer key and the month itself. We can use a function. Now, as you're writing the functions in Prophecy, we give you an expression builder as well, right? So that really the only thing you need to know is basic functions, almost like from this Excel formula, maybe a little bit of SQL expressions. That's the only thing you need to be truly productive. At the same time, we would like to, of course, now that we have the group by, let's aggregate and sum up our amounts. So we have our total prices, which I can sum up and create my amounts column. Perfect. So now that we have our aggregate, we can already see that the data has started flowing through our pipeline as well. And we're processing all of those hundreds of thousands of records. This is how our orders look like, where I have a row, every single order represented as one row, and my customers. After joining the data together, now I have all the orders associated with their corresponding customer. If I want to, I can deep dive into this data as well and see specifically the profiles available for every single column. Cool, so we have our join, we have now our aggregate set up, but I really wish that this pipeline was running a tiny bit faster, right? This is running really well on Photon. We're still processing a lot of data here, but we would like to run it a little bit faster. The typical practice would be to set up some smaller development data samples, but who really has time to build those? So thankfully, Prophecy provides you a bunch of different usability tricks to make this more productive. So I can actually limit the amount of data that I'm working with at any particular time, just to enable you to develop the pipelines a little bit faster. I'm just going to limit it to 1,000 records, and let's drag and drop our final target where we're going to write our report. Let's now run it and see how that works. And wow, perfect. Okay, well, this is now super smooth. Awesome. This is the snappy experience that we are looking for. I can see my aggregated data now for every single month. It's just that this data doesn't look beautiful, right? This is not the kind of report that I would like to give to any of my executives. So let's actually see what we can do. Well, turns out that one of our colleagues have already developed this enrich customers subgraph. This is a piece of functionality that someone else has built, but now I can just drag and drop that directly into my pipeline and start leveraging it. So let's see what's going to happen. Can just connect it right into my aggregate before my final write. And let's run it to see what kind of data are we going to get. Of course, every single component that is built out by your team, you can still inspect, look exactly at how it's functioning, or even configure it further. And perfect. So now we can see the data, and wow, this is looking so much better. So we have still our customer keys, that's fine, but now we can exactly see what are the regions that they are coming from, which nation they are associated with. The amounts are pretty formatted, and our months are finally readable. Awesome. So the last step now is just to write this data out. So this is where we are going to create a new data set. This is going to be my gold report that I'm going to write just as another table for now. I can, of course, see the schema available here for me. And this is where I can also control how they like to write this data. Typically, you might just go with something like an override on append, where you're just adding more records to your existing table. But as mentioned, we do have those really nice integrations with Delta, where you can also merge your data back to existing data sets. Right? This is where specifying merges is as simple as just choosing that option, or even leveraging more complex types of merges, like slowly changing dimensions. On the other side, of course, doesn't matter which option you pick, you would just get high quality code. So with that, let's create this target. And perfect, we can just run it one last time. Awesome. So while this is running, let's also look at the code that is being generated for you from all this hard work that you're putting in. I can just, with one click, switch directly to the code editor. This is where I see my pipeline and all the standardized code files available for me. So I can see that every single gem that was on this canvas is now turned into this really neat function directly inside your PySpark. I can click on any one of them, explore how they are being written. And I can, of course, even explore my actual subgraph that I have dragged and dropped from someone else. If you're a programmer, you should start feeling right at home by looking at this interface. Okay, awesome. So we have finished the development of our pipeline, but this is not a one-time report that we would like to run. We would like to recompute this actually on a daily basis. And so it turns out that I already have a job created here. This job was just running all my ingestion and bronze cleanup pipelines for me. So this is where I can just, at the end of this, add one more pipeline. Since that pipeline already exists, I can also just drag and drop it directly and connect it to all my sources. With that, that's it. Now you have created a complete schedule for your pipeline. There is just one small step left. So remember when we talked about the best development practices? Our code should be versioned, it's placed on a specific branch, but it also should be reviewed by our colleagues, right? And then you should be able to deploy it using a standard mechanism to the right production environment. Well, this is where the releases come in. So I can click on this release button, which takes me directly to the Prophecy Git manager. Now, some of you already might not Git, and you might be even experts in it, but even if you are, you probably know how sometimes difficult it is to work with it. Well, we're making it easy for everyone. So you can see that we are now on this development branch, but I can go ahead and start committing all of our changes. So as you can see, we've built our gold reporting table that we can now commit further and push all the way to our environment. At the end, the last step is the release process. This is where I can just type in the new version of my pipelines that I would like to push into my prod. I can type some release notes and push it out. And this is where we would take care of actually building all the artifacts, running the unit tests for you, and finally deploying the Databricks workflow and the actual code on the Databricks environment. This might take a few minutes. But as this pipeline is deployed, you will start seeing it automatically on the Databricks interface as well. As we said, all the workflows that we develop are just standard jobs on top of Databricks. So now, as soon as this is done, perfect, it's finished. We can also now see this daily job being created and visualized on your Databricks interface. Awesome. With that, that job is going to now start running daily, and we'll be able to see all the data flowing out. But what is the easiest way of monitoring, if not just looking at the actual runs of our pipeline and checking the data produced by it? So what Prophecy enables you to do is to run simple observability on top of your pipelines. I can open up my gold NRR pipeline and see all the historical runs for it. How many records were processed, at what time, how much time it took. This is really awesome. I can open it up as a visual representation on top of my pipelines and even step through as I was developing my pipeline, right? So not only available for scheduled production runs, but also available for your development, debugging, maybe benchmarking needs. Perfect. So now we have walked over the complete end-to-end demo of building a new pipeline. We've done it in just a few minutes. And not only we deployed it to Databricks, we have actually also looked at the code and we started observing our pipeline. So Sushant, back to you.
Great, thank you so much, Maciek. So now let me share my screen. Here we go. All right, so now we are going to do the iPad giveaway. So we are going to go through, hopefully they're still here. And Mangesh Patel, let's just make sure you're on. Looks like you are. Okay, awesome. You win the first iPad. And the next person is Nikhil Vichari. You get the next iPad. So with that, let's now switch over to the question and answers. So I'm sure you may have questions. We already see some in there. As we're answering questions, we have some resources for you to check out. The one on the left is for a free trial, so you can see how easy it is to use a data lakehouse with low code. The one on the right is if you'd like to learn more about Prophecy's low code platform running on Databricks. So with that, let us now switch over to the questions and pull that up. All right, first question. Question is, we have some custom data frameworks in our company. What do I do with these when I use low code? Maciek, can you address that one?
Yeah, absolutely. And so Sushant, by the way, I think we're getting a message that we're not seeing your screen in case you do want to share that.
All right, thank you.
Perfect. But coming back to the question, so question was, what about my custom data frameworks in our company? What can I do with those and low code? Well, this is where your gem builder really comes in, right? So if you have already a skilled data engineering team, they might be fairly new to Spark itself, but as long as they know a little bit of code, they could integrate all of those frameworks directly into Prophecy products and make them available as essentially gems. So if you have your own data quality needs, your own auditing logic, your own logging mechanisms, all of those things can just be very easily integrated into the product itself.
Excellent. Here's another question. How is Databricks able to achieve the data warehouse performance on top of a data lake? Jason, I believe that's for you.
Oh, yeah. We so at Databricks, we developed a brand new engine called the Photon engine, and it's basically rewritten from the ground up using C++ and vectorization techniques. And so that can basically, it's completely 100% Spark API compatible. So you can take the same Spark workload that runs on open source Spark, run it on Databricks, and it'll run on average about 8 times faster. And in the cloud, time is money. So if you can run something faster, that means your virtual machines are up and running for a short amount of time, and you end up saving money. So
that makes sense. So this one I think fits along. Jason just talked about time is money in the cloud. Databricks is based on consumption. So the question is, how is Prophecy priced? Maciek, would you mind answering that one?
Oh yeah, absolutely. So Prophecy pricing model is actually really simple and works well with Databricks. So Prophecy pricing is based on a user, right? So the more users you have, you're just paying a per user license, and the pricing is fairly transparent. So if you just open up our website, all that information is there available for you. Also, if you're wondering, hey, how can I actually make that payment? You can very easily integrate with and pay through your cloud providers. So if you're using already Databricks, for instance, on AWS, Prophecy is also available in the marketplace. You can just load it up directly from there.
Excellent. And then there's another question, I think, for you, Maciek. Is Prophecy low code only for our kind of more inexperienced data engineers? Will our more senior data engineers, the ones that are good at programming, use it? What have you found, Maciek, with companies?
Yeah, that's a good question. So I think, the whole intention is to make people more productive. Doesn't matter what is your skill set. But this also comes about, leveraging your capabilities and leveraging your skills at the best level possible, right? Senior engineers should not be wasting their time rewriting the same pipeline 5 times, right? They should be focused on the underlying framework. They should be focused on the underlying architecture and making sure that people follow those standards that they develop. So this is where, thanks to Prophecy, right now they can focus on building things like subgraphs that we, for instance, showed in the demo, creating those gems, making sure that your data sources are working optimally, as opposed to, again, just rewriting and rewriting the same data pipeline.
Yeah, I would say I would second that. I mean, I feel like this is all about, meeting users where they're at. And if you're more productive, writing code, then, you shouldn't stop doing that. And we've also I've just talked to a lot of data scientists where, they get hired in these companies. Sometimes the first data scientist and 70% of their job is just wrangling all this data to get it ready to do a training session. So something like this allows them to accelerate that part of the job that some might consider mundane, and then get straight to the part where they can add the most value, which is training these machine learning models.
That makes sense. So, Jason, there's a question that I think fits well with what you just said. How does Databricks enable collaboration between data engineers and data scientists?
Yeah, so we've got, I think the main thing is having one single platform where you can have these different use cases and different users use it. And that means you can have, a data scientist and a data engineer logged into the same workspace. We've got interactive notebooks, so you could be doing some data exploration on a notebook. And then if you get stuck with something, you could share that notebook. It's just a URL with someone else in your organization and give them access. And then you can basically pair program at the same time in the same notebook. You can leave, comments just like you would on a Google Doc. So it really does allow that cross collaboration to choose how much do you want to share, and then being able to collaborate regardless of where those two people are in the world.
All right. Here's a question I think both of you should probably address. Will low code be able to scale on Databricks? And, kind of what are the limits that people should be aware of?
Yeah, so maybe.
Oh, sorry, go ahead. Either one.
Oh, maybe.
No,
yeah, Jason can take the
first.
Databricks scaling part. I can take the Prophecy scaling part.
I mean, essentially, Prophecy is generating code that gets run on the Databricks platform. And, that code is running on, clusters that can scale out to your largest data sets. We routinely work with customers who are processing petabytes of data. So, and, the reason is because it's leveraging Apache Spark, which, our co-founders were the original co-creators of, and we've optimized that code. And with our Photon engine, we can actually make the same code run faster. So.
Oh, so I think that's really well articulated. And even just to add to that, right? Prophecy and Databricks work, of course, hand to hand. We've been even, running and testing, of course, our code all the time, right? So we have some set of benchmarks, whether that's TPCH, TPCI, TPCDI, and we have them developed side by side, right? Developed one in low code with visual drag and drop, right? Another one written by a data engineer that really knows Spark, and optimized by them. And what we found in almost every single case is that the performance was equal. Right, so we are really aiming at making sure that the code generated is as high performance as possible, almost as if an actual data engineer with all that Spark experience wrote it by hand.
I think it's also worth noting, there's some low code solutions out there where the vendor is building the user interface, but they're also building the engine to do all those transformations. And in that situation, that one vendor is going to have to be really good at building an engine, making it scale. And there's only so much R&D to go around. So for something like this, where you're kind of leveraging the engine and the scalability that Databricks, has been investing in for 7-9 years now, you're not going to beat it. We've got the power of Databricks, but also the power of the community behind open source Spark and Delta Lake that have been making things improved every day. So
excellent. Looks like we have time for one or two more questions, and I apologize to see the other questions. I have to switch screens, which stops the sharing, so I apologize for that. There's a question that's asked: how is this different than Alteryx? Jason, you want to go take first, and then Maciek?
I'm going to defer to Maciek because I feel like he gets this question probably day in and day out.
Yeah, and funnily enough, we do have a lot of people actually coming from Alteryx and trying to migrate to Databricks and the Prophecy stack. I think the biggest difference is kind of what Jason also mentioned as well. Alteryx has essentially its own engine, right? So when you're running and building your own pipelines, there's only so much you can do on that engine, and you're really not able to leverage all the big data capabilities that come with Databricks. So once you switch to Prophecy, now you can start building, running code that actually scales and runs on much, much significantly bigger data sets. At the same time, Alteryx is completely lock-in, right? I mean, this is something that we touched upon in our presentation. What Prophecy gives you is high quality code, right? How you want to run it, what CI/CD you want to use, where you want to run it, on which Databricks workspace, how you want to package, all of those decisions are left upon you, and you can do with that code whatever you'd like. All of those traditional ETL tools or analytics tools like Alteryx lock you into their format. So then you're stuck with what they provide you.
That makes sense. I think we have time for one last one. Took a quick look at the questions. There's a question about how do you manage access to the data product in Prophecy? Maciek, do you want to respond to that? And Jason, if you have any comments as well?
I think this is super easy because we are essentially just sitting as a layer on top of Databricks, right? And this is where Jason can go into more details. But when you're logging into Prophecy, you're just using your standard Databricks credentials. You have a token created for you, and all the permissions are essentially pass-through. So then we're just leveraging all the ACLs that are there available for you on Databricks directly.
Yeah, and ultimately you're outputting a Delta table, and that Delta table on the Databricks platform, you can leverage our governance layer to be able to grant access to the users and groups that should or revoke the access to people who shouldn't have it. So
okay, that makes sense. So we got 1 minute left, so I think we're about out of time. Jason and Maciek, thank you so much for your time today in helping everyone understand low-code data lakehouse, as well as giving the demo. As a reminder to everyone, you will be getting an email with a link to the recording. So hopefully you were able to, get yourself educated and learn more about low code on data lakehouse, and it can supercharge your data analytics efforts. And I just want to thank you for attending today. Thank you so much. Bye now.
Awesome.
thank you, everyone.
This was a pleasure. Thank you.